Uh, right. Um, what have I been up to over the Christmas period? I have been working on more optimization things. Okay, let's actually try to explain exactly what the issue is. Um, so this is the latest Patreon build. This is what I've been working on for I think all of December. I started in like mid-November, and then I've been working on this ever since. Um, I have this is like an old project file that somebody sent me because it was broken, and then I fixed it and sent it back to them. And I noticed they had all these other workspaces, and some of them were like really massive. So I thought I'll hang on to that because it's a good like test project. It's got all this stuff in it. So I'm zooming in and out with the mouse wheel here, and you can see things are really sort of chugging a little bit. Like it's not as smooth as I want it to be, and sometimes it really like when there's not many blocks on screen, it's pretty smooth, and then when there's lots of blocks, it starts really chugging. And just not as smooth as it should be. And so I started tackling this issue from like a bunch of sort of different angles. And by the way, I have a pretty beefy computer as well, so it's probably even worse on other people's computers. Like if you're just using a little laptop or something, it's probably even worse, even if the display is smaller. Um, I guess it's usable, but I'm not happy, especially when you get to like. And part of the bottleneck when it's like switching over to from like this full block view to these like colored rectangles. Um, in this build, I think like Godot nodes are like going in and out of existence and being added or removed from the scene tree, and um, part of the motivation behind these colored rectangles that everyone hates is optimization, because as soon as it's like a flat color, like the full block fully fades away. Yeah, actually, that the control actually is, I think, removed from the scene tree entirely, so it's not contributing to all these calculations that are happening. Um, um, but that's not going to be necessary in the future, because of the optimizations that I'm adding now. I'm sort of fixing it all the problems. So one of the ways that I approached this was to think about cache locality. So from the start, blockhead's been written in this very object-oriented style, and I started moving things out of this object-oriented world into a data-oriented sort of structure. I have a bunch of structs of arrays and things. If you don't know about data-oriented design, it doesn't matter. But it's something that usually doesn't matter. Is that when you write things in an object-oriented way, you end up with things scattered around in memory in different locations, and that like in general slows things down in a way that usually does not matter. People who are like really into data-oriented design really overstate how much it matters. It basically matters in cases where you are iterating over lots of things and updating lots of things very quickly, which is the case when I have Like I'm like on the cusp of it mattering in blockhead. Um, oh, I mean, I guess you could have even more blocks on screen than this, so it would matter even more. The more blocks you have on screen at once, the more it matters that I'm iterating over all of these things and updating them. So it matters enough that I started moving things into structs of arrays, and so blockhead's in this like transitionary state at the moment where it's sort of partly object oriented and partly data oriented now, because I can't just rewrite the entire thing over one Christmas. But I've basically moved out all of the relevant stuff is now like more organized in a way that the CPU likes. Anything to do with like calculating where all of these blocks are on the screen when the user is moving around, zooming in and out, and manipulating the view. In the current build, that's all data-oriented stuff now. Okay, the other issue, which I think turns out to be a much bigger issue than that, is each one of these block controls is a Godot scene, and it's a very deeply nested Godot scene because it has all of this stuff inside of it. Even if you can't see it, it's basically there. I was already doing a few optimizations where some stuff I only add to the scene tree when it's needed and then remove it when it's not. But stuff like, even if you're not using it, like this chord editor is always here in the tree, even if it's not visible, or if you've not even got a plugin selected that has chord parameters. So these nodes can get very heavy, and so I spent a lot of time optimizing them and trying to reduce the total number of child nodes in each of these controls. So the current state of the sample block control, for example, which is probably the most complex, is very small compared to what it used to be. So each one of these is potentially a subscene with even more children. I think the most heavy stuff is probably the header still, because that has all this stuff in it. So I've optimized that basically as far as I can go. And I don't particularly want to. In the past, I've done stuff where I've sort of like dynamically added and removed things to and from the scene tree, as and when it's needed. But that is such a nightmare to keep on top of. That causes even more. That's like solving one problem by introducing like 10 other problems. Anyway, so I did all that, and then it was like day before Christmas Eve. Oh no, one other thing I did was I forked Godot, and I added a blockhead specific optimization to this control size changed function, where I think the optimization is basically this. I added this. Which seems to speed things up a lot. Basically, every time a control changes, it will no longer notify. But when control, it's too hard to explain. When the control changes, it will like recursively notify all of its child nodes that it'll just recursively send this notification resized signal to all of its children. So recursively, every child node comes into here eventually. and I just put this check to say if it's not visible, then stop recursing, because when it's made visible, the next time it's made visible, this will happen again anyway. Which doesn't break things in blockhead, but can potentially break things in other people's Godot projects. So I submitted a Godot issue about it on the GitHub, but I don't think that they will actually do this change, because it could potentially break things for other people, and most people are not doing blockhead type things because blockhead's not a game, and so I'm using Godot in a weird way where I'm really heavily using control nodes for everything, and I have a lot of control nodes on the screen at once, and when I'm calculating the geometry of all the blocks, this right here is the bottleneck. The control size changed function. This is where it all goes down. Right. So I did all of that. I did all of those changes, and they got to be like the day before Christmas Eve, and I was just using this project file as a test, and just it was it's a lot better than this now, but I still wasn't happy with the performance. I didn't get as much of a performance increase as I hoped, because I would really like it to just be like super smooth all of the time. So then I had an idea, which is how to explain, maybe with MS Paint. So most of the time, I think I've been having this problem as well. What's going on? Sometimes that no button doesn't work. Alright. So, my idea. You have you have these block controls, which have all of these controls on them, and a lot of the time these controls are not visible at all. And with the sample block, for example, you have a waveform there. And when a lane is not expanded, when a block control is not expanded, or when it's just really small and too small to interact with it in a meaningful way, the only thing anyone really cares about is the waveform display. And that's also the complaint that people have with when things get really small and it gets replaced by those coloured rectangles, is they can't see the waveforms anymore. Like even when the horizontal width is very small, it's still useful to be able to see those very small waveforms, and they can't see them. So what I've decided to do now is every time I create a block control, I'm also going to create, in code I've been calling it a backplate. So I'm going to create this control behind it, which is an extremely lightweight control, which literally just has, I'm going to need different types of backplates for the different types of block, because they have different visual elements on them. But it's going to be responsible for drawing these very cheap visual elements. It basically has no child nodes at all. It has no interactable elements at all. All it is very simple visual elements and waveforms. So when the block is not expanded, this entire thing is just going to be invisible, and I'm not going to be calculating the size of that at all during like zooming and panning operations. It's just going to be this backplate that's visible. And as soon as Um, as soon as the controls actually need to be visible, I actually make this visible again. So this actually will not have. How do I do this? This won't have a waveform on it at all. This middle part is just going to be sort of transparent, and you'll be able to see the waveform through the middle. You'll be able to see it on the back plate here. So I started working on that, and it seemed to be working really well for my initial tests. It seems like an extremely good idea. Like this is going to be, give me a much bigger performance increase than what I was seeing before. I think that's what it seems like. And so I got halfway through working on this, and I was basically just in refactoring mode again, just like wiring all the code together and making things work again. And it got to the point of like trying to, because I'm doing things related to waveforms, and the waveform rendering, like I have like a back end and a front end of the waveform rendering, and the back end of the waveform rendering is not changing, but the front end is. And the front end has always been written in such a stupid way. Like it was written in a really dumb way, and then because I have all these different types of waveforms, and I have different ways of displaying waveforms in different contexts, and I also have different sources of waveform data. Like I have a whole bunch of different places that you can get the data from to display waveforms. So it's a complicated problem, more complicated than it seems, and so it was written in a dumb way to begin with, because I didn't know what I was doing, and then I was like, okay, I understand all of the ins and outs and the parameters of the waveforms now. I'm going to rewrite it in a better way, and that was around the time that I had become very interested in this concept called type erasure, which is sort of like in certain niches of the C++ world, some people are very excited about type erasure, and it's basically a way of structuring programs. It allows you to think about things in terms of interfaces and pass things. So I have these two concepts for displaying waveform. I have a display mode, and there's like 3 different display modes. There's and then there's a source type, and there's like, I don't know, 10 different places that waveform data can come from. So I have like a bunch of different display modes, a bunch of different source types, and they have to work together in one, like, at the end of the day, they both have to be passed to like the waveform control, and they have to work together to display the waveform on the screen. And it's a giant mess. And I thought, I know, this type erasure stuff is really cool. So I'll write it all in terms of type erasure. And so I ended up with like a display mode type erased type, and a source type erased type. So if you understand what type erasure is, you know what I'm talking about. Anyway, it turned out to be a really horrible idea. I really regret doing it. But I didn't know how else to do it at the time, so I guess I don't regret doing it. But I've learned a thing or two since then about how to write software well. So type erasure is really stupid. I hate type erasure now. At the time, it was like, wow, type erasure is so cool. You could just do everything with type erasure. And it was sort of popularized by this guy called Sean Parent, who works for Adobe, I think. And we probably shouldn't be taking software development tips from Adobe employees, to be honest. So if that's a bit snarky, but How long is Adobe Photoshop taking to start up these days? I wonder. It's been a while since I tried it. Maybe it's really fast. I don't know. Anyway, so this is my new waveform rendering code that I've been working on. It's not done yet, but it's so much better now. Now that I'm just doing it, it's just super like procedural, and I have a few like function tables for the different types of things. I don't know what point the code is in now, because I've just had a 2-day Christmas break. Is this just crashing when I try to... Okay, no, it's displaying waveforms. I've really reduced the threshold at which these turns into these coloured rectangles now. I might be able to just eliminate it entirely eventually. It's probably a good idea, because I don't think it's going to be necessary. So I have one waveform display mode that I've filled in here. I have a bunch of to-dos for the other types of drawing that I need to do here. This is for rendering icon, is for render window is for the input buffer. The waveforms have to be rendered in a particular way, where they are not in a way that they have to be rendered in a particular way for the input buffer. And then render icon is for the waveforms in like the sample browser and the block browser, and certain dialogues where you resize the size of the you resize the parent control, and the waveform sort of stretches to fill the control. Anyway, the only one I've filled in so far is render workspace, which is the one that's used for I guess it's the most complicated one. Is the one it's used for rendering waveforms on the workspace, so the block waveforms. And I've simplified this to remove the caching that I had before, because I don't think I'm going to need it anymore, because I'm actually rendering everything in a more cache efficient way, I think, because I've learned a thing or two about cache. Well, I've always known about cache efficiency and cache locality and how it all works, but I've never had reason to put any of it into practice before, until about a year ago when I started doing all of these blockhead refactors. And I started thinking about it more. So I sort of know more what I'm doing with that now. I don't think the caching is going to be needed. So the way the caching worked is anytime you make like a change like this, obviously the entire waveform needs to be re-rendered, because every pixel of the waveform is changing. But if you're just like zooming in and out, this is re-rendering the waveform for every zoom level. And I have a rule where it's like, if you zoom in and it re-renders the waveform, if the entire waveform is visible on the screen, which it might not be, it might be like partially off the screen like that. If the entire waveform is visible, then just cache that image. And the next time, if it hasn't been dirtied, then just reuse that image instead of re-rendering it. And I did a few tests in the beginning and found that seemed to help the waveform rendering along a little bit, having that optimization. But I don't think it's actually going to be necessary, because everything's going to be so fast anyway at this point. So I've just simplified everything by not doing the caching anymore. And if I feel like I need to do the caching again, I might add it back. But I don't think it'll be necessary. Even if the entire workspace is full of waveforms and you're zooming in and out, then I think it'll be fine. We'll see. What else was I was going to say something else. Oh yeah, that's it. So I'm scrolling my mouse wheel here, and I have one of these. Obviously, mouse wheels have these sort of clicking points where it's like so it's like fixed intervals of zooming, and this is basically cycling through these fixed zoom levels that Blockhead has. So you can't go in between this point and this point, for example. And that's a problem for Mac OS users who are used to using pinch zooming on their trackpads that they love so much. And they're going to expect everything to be smoothly zooming, not just cycling through these. You see this error here? This is to do with the caching, I think. This is a caching issue. Oh no, this is the new build, isn't it? Oh no, that's just because everything's broken at the moment. And so I forget that. What was I talking about? Yeah, trackpad zooming. It should be smooth. You should be able to like pinch with your fingers and do a very smooth zooming gesture to get to exactly the zoom level that you want. But you can't do that in Blockhead at the moment. But now that I don't have that caching system, as long as I have that caching system, it's not going to be possible to do smooth zooming. It's always going to be stepped like this. But now that I don't have the caching system, I could just do arbitrary zoom levels if I want to. If it turns out I don't need the caching, then eventually I will switch things to using smooth zoom levels. Okay. Right. So that's the display mode. So you see I have these two concepts, source type and display mode. So this is the one that I've done, the workspace display mode. And the source type that I filled in is just sampler block instance, because we're only looking at sampler blocks there. Sampler block instance, which is there's a few different functions, and I have these function tables to switch between these functions. So yeah, I need to fill in one of these for every source type. And one of these. So in this case, I'm reading the bitmap. And I need to fill in, oh yeah, one of these, which is just referring to this function. So I've got all these to-dos for these different types of source, waveform source data. Oh, and I filled in the baked data as well. I think I was in the middle of testing. I was in the middle of doing this actually, the baked data, before I went on Christmas break, and oh yeah, this get source info thing that I need to fill in. I need to do this for every source type. Okay, so everything's sort of well structured in this file now. Yes, I did this already. If I create a synthesizer block here, synthesizers don't have like a real-time waveform, but they have the baked waveform. I assume this is just going to crash because I haven't done anything to make synthesizer work yet. Okay. So first of all, let me have a look at the control. See what we've got here. Have I stripped it down properly? Yes, it looks like I have. Okay. Let's see what's happening then. So update real-time waveforms. This shouldn't be happening because the the synth block has no real-time waveform. Update real-time waveform, so we go in here. Exactly, okay. I'm gonna go get type of block ID. And dump all this in here. Okay. Essentially what I'm doing is filling in all of these to-dos, which most of them are in here. That's my current task. But there's other stuff that I'm pretty sure is broken right now. Stuff that I don't know about yet, or stuff that is not represented by a to-do in the code. There's other things that are broken, so I'll have to investigate. Also, what waveforms are not appearing yet until you do this, and then they appear. So I need to solve that. So now where does it crash? Get real-time waveform. Okay. On block instance real-time waveform changed. That should be happening. On block instance real-time waveform changed. Yeah, I should be checking this flag. Anytime I do this. Flags. Where do flags come from? Config flags. What is all this? Oh, is that the... Oh, those are the parameters. Oh dear. That's not what I thought. Oh, right. That's fine. Okay. Block instance real-time waveform changed. Well, this is awkward. Okay, for now I'm just going to let's do the same thing again. And put a fix me here. Might have the same issue here, I'm not sure. So all of this stuff previously was happening through virtual function calls, and so we would have just been entering an empty function for the block types that don't have real-time waveforms, such as synths. Okay. Woo! Okay, wasn't expecting that. Okay, before I look at that, we should at least have... baking's turned off. Okay. Okay, here we go. Get receivers. Wait, did I create the... I created a synth, right? Okay, this shouldn't be happening. Oh. I'm assuming that it's a send here. But I can actually just send receivers find instead. Oh, it's returning a reference. So I am assuming that is definitely a send if I'm calling that at all. Okay. That's fine. Type of this. So when you're not doing things objects oriented, you end up, well, I'm still learning this stuff really, but I've found that you end up doing a lot of this manual type checking. Which is basically what you're trying to avoid when you do object-oriented stuff, I guess. Look at... Okay. Okay, the baking was fine, it looked like. I don't want to ever do that. That's scary. So the baked waveform is not appearing. Which makes sense because that's the stuff that I'm working on right now. So why is the baked waveform not appearing? Let's have a look. So I have these backplate classes now, which are Godot classes. Backplate bakeable. So every time I change the zoom level, this should happen again. Okay. Render if dirty. Update shader params for block instance waveform. This all looks correct to me. Oh, lane pixel width. Oh, there's no check texture. Okay. That's all fine. Then we go in here. So it is rendering everything. That sounds fine. 200. This part is not... Oh, this is the vector that I'm going to fill. Okay. Yes. These are the block space positions. That all looks... So this is like I said earlier, there's the waveform rendering has a front end and a back end. When I said back end, I'm talking about a bunch of the the complicated mathematics and logic of figuring out. So I have a list of pixels, like say the width of a block on the screen is like 200 pixels, which I think actually is 200 in this case. So I have 200 pixels that I want to render. I send those pixel positions to the sampler plugin actually, and the sampler plugin will actually do a bunch of. No, that's not true. In this case, I'm doing baked rendering. So, okay, it's very like I said earlier. There's like the waveform rendering is complex because I'm rendering waveforms in like 10 different ways, 10 times 3. What is it exactly? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3, roughly. Some of these will not overlap, but anyway, so I started talking about like how the plugins do the back end of the waveform rendering there, but in this case that's not happening because it's a baked waveform that I'm rendering, not the sampler plugin waveform. So in this case, the back end is just a function, I think. But anyway, I get these block space positions like this, which is just a function. If I was doing real-time waveform rendering, these values would be passed into the plugin, and then the plugin would return the list of actual sample positions that correspond to these block positions. Anyway, none of this makes sense. Let's just keep looking, see if everything makes sense. This all looks fine. We already have a buffer, it seems like. Yeah. Draw result. Let's have a look at this. This all looks fine as well. Okay. Then we're actually going to. This is all fine. Okay, let me get to here. Source frames. So by the end of this function, I should have all this. Did I not fill in this function yet? Ah, here we go. Here we go. I didn't write this yet. So everything makes sense. It makes sense that there's no waveform. Okay. So this is the one. Right. So I'm just going to go into my old waveform drawing code, which is here. Everything in this directory, basically. See, I have these display modes and the sources here for all the different types of waveform rendering. So the one I'm interested in here is baked output. Read source baked output, which is this function, which used to be called get min max. But I basically want to do this. Read source baked. So these function signatures are no good, actually. I need the drawing context, I think. Read source. I need this drawing context. Okay, yes, any drawing context. Legitimate use of standard any here. It does happen in the wild. You're witnessing it, the legitimate use of standard any. Has nothing to do with implementing a scripting language. Okay, read source standard any drawing context. Okay. What's the problem down here? Yes. I had to do the standard anything to solve a multi-threading issue actually, because I need to see if I can show you. Drawing context equals. When I start rendering the waveform, I'm gonna call this function once to get the source info. And this, I'm gonna get a shared pointer to the baked data, for which holds the actual data for the baked waveform. And to do that, I'm calling this scary function, which is phasx is a gibberish word, which identifies a certain subsystem of blockhead, which is basically this background processing thread that sits as an intermediate layer between the UI and the audio thread. It's in its own thread and it does things in a horrible multi-threaded way. But occasionally it finishes its processing that it's doing and it will like publish a mutable model of the current state of the system. And so when I call this function, it has UI underscore underscore in front of it, which is my convention for saying this is safe to call in a UI thread. And all it's going to do is get the latest published model, the latest published version of that model, which is where I need to get this baked data from. I don't want to call this multiple times during the course of rendering waveforms, because it might return different shared pointers, because there's multi-threading involved. So I just want to call it once, and then I'm stuffing it into this drawing context so that I can access it again later. And I know exactly what's going to be in there because all of these functions are like typed. So I know exactly what type of data I'm dealing with here. So I do an anycast like this. I can go context, data, get bitmap to get that. Bin size. Now hold on. How does this work now? Because I don't have a bin size. I changed this. I changed this. How does this work now? Oh. Oh, yeah, okay. Yeah. Okay. Does this... It's basically this loop that I want to do. Bin size to LOD. Sample data read frame. But this is in a library, isn't it? No, it's not. It's right here. This is like really old code now. This is Don't think this code has changed for a long time. I can tell because I'm using class. I never use class anymore. I want to move this loop into there, I think, because I'm going to reuse it besides the LOD. So I'm taking in this vector of frames to read instead, and a vector of output frames. Okay. I don't know what I've been. So I've been recording for 50 minutes already. Most of that's just been talking. I don't know how long this is gonna be. I don't know at what point I'm gonna stop recording. I do know that when these videos are like really big, it's a massive hassle to upload them. Maybe I'll just deal with it. I'm getting lost in my... Okay, here we go. Sample summary. First of all, struct. Everything's a struct. Get rid of all this white space that I used to sprinkle everywhere. Sometimes I'll do this where I'll encounter a bit of code that I haven't worked on for ages, and I'll just take a moment to look at it and decide if it all looks reasonable. Put no discard on all these. I've started doing this everywhere as well. Okay. Sample data. Let's take this. Wait. In frames. Oh, channel. Yeah. Okay. Oh, I'm using an atomic variable for this, which is fine. Maybe not the way I do things these days, but okay. Read. I'll just read what I want. Something like this, actually. Sample summary. Which apparently I use uint 16 here now. Not uint 8. Don't I have like a channel? I think somewhere I have a channel count. Whatever. Let's not rock the boat. And let's return this instead of doing that. No, that's a terrible idea. Well, it's a fine idea, but I don't want to do it. I want to reuse these buffers without doing extra allocations, if I can avoid it. Even though I suspect the optimizer would see through a lot of this and eliminate that allocation, but it's not that bad to do this. Okay. This. Excuse me. Read. Okay. What do I need here? Surely I need this now. This is a pretty new addition to Blockhead codebase. It happened, I think, in the summer of this year. I created this file called t.h, which is meant to be a reasonably lightweight header, which is included all over the place. But it has a bunch of like strongly typed integers for mostly IDs. Because I used to just have this generic ID type that was used for everything. It's just like an int that is incremented by 1 every time I need a new ID to identify an object. But I was just using that ID type for everything, and it's kind of bad to do that because you can end up, you have a function that takes like a lane and a track ID, for example, and it's possible to get them the wrong way round or whatever. So I ended up creating all of these strong types. But because C++ is so bad, you have to like manually write all of the operators that you need. But yeah, I quite like this stuff now. And then I have some other enums and things in here. Good idea, even if it's a lot of boilerplate. Just trying to work around C++ limitations. Just staring at this code. Is this fine? Looks okay? Okay. So now I can just go map read channel frames out frames in frames out frames. And now I can use that in here, wherever it was. Map read channel, which is a size T. I'm going to need to cast that. I think the compiler is going to complain. In frames, out frames. I don't have those though. So how does this work? Oh yeah, the work buffers. Yeah, that's how it works. So I have these buffers that I like reuse instead of reallocating the vectors. Yeah, read frames. Source frames. Like that. Is that how I do it? Read frames, source frames. And you're going to tell me what? This. It's not const, but it should be. It should be extremely const. Okay. Hold on. And now what? What am I missing? Sorry. What are you unhappy about? Sample read frame. I've missed something here. What am I missing? Huh? Oh. Oh. Right. I see. So this sample summary thing is a wrapper around the sample bitmap to add some extra operations. And that's not what I have access to here. In here, sorry. This bitmap, what this get bitmap does not return the sample summary. It returns the actual underlying bitmap. Oh man, really? Why? Can I just... I'm just not using this sample summary for baked data, it looks like. Frames written, yeah. Get frames written. Oh, I use it for writing as well, that's why. This is a badly named class, actually. So with baked data, do I write? I do write. But I don't want to go through this to write. Or do I? Frames. There's like no thread synchronization on this at all because it's all handled by the immutable data structures that I use. So I have this write function. Okay. This could stand to be a little bit better, but for now I'll just sample summary. Why am I using... I don't even need... Yeah, I do. Okay. This is... So now that I've been straying away from object orientation for a while, sometimes I start to see the pain in expressing everything in terms of objects, but at the same time, I sometimes like really miss object orientation for some stuff. Sample summary, okay. Sorry, my head's all over the place because I'm just thinking about 20 different things at once. Okay. Get summary. This is such a bad name. It's just a wrapper type for the bitmap, but whatever. I do want to rename it. Sample summary. Like that. No, it has a different constructor. So this has channel count, frame count. What does this have? Channel count, frame count, detail. Okay. Get detail level. frame count. Is that what I'm doing? Yes, exactly. So I can do this. Why am I doing that? Because I didn't know about this when I wrote this code, I guess. Oh, you can't do that in a ternary because they're different types. That's funny. So that's what I do. I was correct to do that. No? Still doesn't like it. Sample summary. Let's see. What am I doing wrong? Doesn't like this. Operand types are incompatible. Sample summary. Why did the other way work? Why did this fuck shit work? Excuse me? Huh? The fuck? Why does it work with this type? I'm not doing... This is what it was. C++. I don't understand C++. That is mad, isn't it? What is going on there? Whatever. Right, if not, this... Otherwise return... Excuse me, can you... Excuse me, yep. Okay. Huh. Hold on now. Is it because of it's not a movable type because it has an atomic in it? It is not a movable type. I think it has to be movable, huh? That's why the ternary wasn't working. It has to be a movable type in order to do this. Interesting stuff. I can do it in place, I think. I think that still won't work, actually. I think I have to do it like this. I have to go in place. Like that. The fact that there's no red squiggly doesn't mean much. It might still fail when I actually go to compile. So if there's a summary and summary right, that's now going to go through this wrapper function. Which is not actually what I want. I want to be calling this. Right. Why am I doing all this? I can't remember why I'm even doing this. Because I want this read function. That's the only reason. I just want that read. This is stupid. This is what I was talking about with right, undo. This is what I was talking about. With being object minded. Like doing object orientation all your life. It makes you think about some things in stupid ways. So this shouldn't be a member function. It doesn't make any sense. It should be like this. Let's just do this. If I just done that from the start, I wouldn't be fucking around trying to understand C++. So now I can go like this. Should be able to, right? What is this? Sample summary? No. Well, maybe. Put this back in. I just call my free function. Wait, this is hold on. Did I not undo far enough? Undo. What? I've confused myself. Oh, yeah. Sorry, I'm really confused. So this should be like this. I fucked up all my formatting again, that's fine. Let's do this, blah. And you're saying, why don't you use Clang format? It's because it doesn't do... I can't get it to do what I want. It's really hard to get it to do actually what you want. Okay. Also, it's quite therapeutic, like going through and and it forces you to look at actually like just eyeball code that you actually wouldn't be. So this is all my rationalizing and copium that I come up with in my head to justify why I do things. Okay, so now oh sorry, so this is working now, and now this I can go read map like that. Finally, okay, we got there in the end. What's happening now? Okay, I need to pass in stuff. Where do I get the drawing context from? I don't know. Drawing context. It's part of the source info, yeah, okay. Source info. Just having a look at the order of these parameters to try and make things reasonably consistent. So WM drawing context, woof. I'll make it the third parameter again. Read source. Oh, that's exactly what I already did. Yeah. Read source funnels. Like that. And then I call source info. Drawing context. Bang. So now it's either going to draw the baked waveform or it's going to crash somewhere else. And I can actually now, these are going to be exactly the same now. So I should make these one function instead. And do this. Which is nice. Okay. Create a synth. It still doesn't render it. So let's see what's going on now. It got to here before. Map. Let's just see, is there something in here? Oh yeah, it's got data. Okay, so the problem must be somewhere else now. I know all of this works because I'm doing exactly the same thing for the real-time waveforms, and I can see that that works. So this is going to just go through and copy all this into this Godot byte buffer, and then I generate a texture from it here. Just look at these values real quick. 471, yeah. So that's all fine. Then we go draw waveform. Yeah, it should draw it. It should draw it. But it's not visible. Okay. Let's do just a check of this. Huh? Get size returned. Yeah, that looks fine. Right. What could the problem be? Bearing in mind these waveforms work fine. And it's doing exactly the same code pretty much. Backplate bakeable. I'm not sure what I've done. Backplate with the right waveform, okay. Backplate bakeable. This is basically the same code. Beep, 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 beep. Very slightly, subtly different. What could I be doing wrong here? Interesting. Just doesn't show up. And I can see that there's values being written to that buffer. Get waveform material, is that doing the right thing? Synth. Get material. Add. Initialize. Yeah, it's just doing this. Right. I mean, I know all of this is correct. So everything's, from the code point of view, everything seems to be doing exactly what it should be doing. Source frames. Here's all my values. That looks like values, yeah. Everything looks like it's working. I know all this works because I'm doing exactly the same thing for the real-time waveforms. I know all of this is correct. Because otherwise this wouldn't work. Please don't do that. That looks so horrible. So there must be a problem in here. But I can see it's all just doing everything I want it to do. The only difference is this. That's weird. I don't like this at all. I don't like this. What am I doing wrong? I cannot think what the problem could be here. Let's just think. What could possibly be wrong here? Yes. I do need to... Wait, is this happening? This happens as well, right? Happens first. Drawing background. I don't know, man. This is just fucking weird. It's gonna be something really stupid. It's gonna be something... It's doing this every time. Which is fine, I guess. There's no textures, no pixel width. I know all that works. What could it be? How perplexing. What's going on here? So the backplate itself is rendering because that's what's creating this color background. This is the backplate that I'm moving around now. But there's no waveform on it, even though I can see that the waveform is rendering. What? And it works fine for sampler blocks. Or for real-time waveforms. This is so weird. I don't understand what I've done wrong. Hey. Fuck you. This is all exactly the same. What? Well, I'm not setting the material. Yeah, I'm setting it here. If I don't set the material, let's see how it looks then. I should get just a rectangle. Right, there's a shader parameter that I'm missing. There must be. I don't know why I didn't have this sort before, but somewhere in here I have update shader params. Update shader params. I must be doing something in here that I'm not doing elsewhere. Num channels, channel mode. For block instance waveform. Channel mode? I don't need that, do I? Oh. Channel mode. I don't think so. Non-channel. Up, 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 up. I'm not setting num channels. That's what it is. Oh. Right. Yeah. Yeah, that's the problem. Okay, so this I'll show you what the problem is. Waveform. No, woofer. Here it is. This is my shader. And I need to set this for the number of channels of the waveform data. So it's either going to be 1 or 2. And I'm just not setting it at all. So I guess it defaults to 0. And the reason I'm not setting it is because I'm just calling this function, which instead I should be calling for block update shader params for baked data, and this one as well, like that. And then I write that function for baked data. And then I just call I just do that. There we go. That took me way too long to spot. That's one of those things where I'm gonna blame the fact that I'm recording. It's still a factor in my brain activity. Having this microphone next to me for some reason. Interesting psychological effect that hey! Oh yeah, I can't do that. I can't do that yet. There we go. And there's no icon right now because that's broken. The context menu is appearing in the wrong place. There's a bunch of broken stuff, but that shouldn't be. I don't know what's going on there. It's like revealing garbage data beyond the end of the buffer. So I need to fix that. Oh. Here's another. This is no. Control header. But I don't have the header, right? Or I don't have the mod. What do I not have? Tree, header, tree, mod param select. I don't have any of this because that's all just broken at the moment. That's okay. Yes. I got the. What did I achieve here? This is a lot of code that I wrote or deleted. Okay. Reforms, refactor. Okay, so I was just trying to find a stopping point for the video and I found it. So there we go.